All right, ladies and gentlemen, we're going to go over Chapter 6, Section 5, Solving Square Roots and Other Radical Equations. So, I think this will be an easier section for you guys because it's nothing new. We're just combining some things that we already know. So let's jump right into this. We're going to look at solving equations with square roots. So hopefully you guys can look at this and do it on your own. You can think, all right, the square root of some number is equal to 4. What number, when I take the square root of it, equals 4? And that number is 16. The square root of 16. Is equal to 4. Algebraically, we can figure this out. If we have the square root of x is equal to 4, we can get rid of this square root here by squaring it. Squares and square roots are opposites. So if I square both sides, the square and the square root cancel out, and we get x is equal to 4 squared 16. So 16 is the only number that when we take the square root of it will equal 4. The problem below it here looks a little bit trickier because we have x to the 3rd power and the 4th root. We can solve it though the same way we did, same way we solved our other problem. If I rewrite this problem as x to the 1/2 power, that's the same thing as the square root of x, because this is x to the 1st power and square root. Remember, we can change square roots in and out of exponential form. If I have x to the 1/2 power and I want to get x all by itself, we need to get rid of this 1/2 power. So the way we get rid of 1/2 power is to multiply it by its reciprocal, 2 over 1. And we can multiply we can take 4 to the 2 over 1 power. So here we get x to the 1 times 2 is 2 over 2 power is equal to, that's basically just 4 squared, right? 16. And 2 over 2 is equal to 1. So x is equal to 16. Another way to solve it. So we can solve this problem down here the same way. We can convert this square root into exponential form, and it'll become x to the 3/4 power. So to get rid of 3/4 power, we need to multiply by, or take it to the power of 4 over 3, and take this to the power of 4 over 3. So x to the 3/4 power to the power of 4 over 3, 3 over 3 cancels out, 4 over 4 cancels out, and we just get x to the 1st power is equal to 3 to the 4/3 power. We can do a couple of things with this 3 to the 4/3 power. Sometimes it might be nice to leave it like that, or we could change it back to square root form, where it would become 3 to the power of 4, the 3rd root of that. And we could simplify this down a little bit. We know 3rd roots, we're looking for triples. And this is 3 times 3 times 3 times 3. So we have a triple 3 here. And left over, we have another 3. So we could simplify it down like that. If we put this in our calculator, we would get the same answer. Or we could even change that to a decimal answer putting it into our calculator. Any of those answers are okay, but you should know what each of them mean and should be able to go back and forth between all of them. Alright, so what you guys are going to be looking at mostly in the problems that you do is something like this. Now, when you see the square root, I think of the problems that we did regarding absolute values. The first step is the exact same. When we had an absolute value problem, we would get the absolute value all by itself first. So we want to do the same thing here. We want to get this square root all by itself. So the way we get it all by itself is getting rid of this 3 here. So if I subtract 3 on both sides, cancels out over here, and I get the square root of 2x minus 3 is equal to 5. Now, I need to get rid of the square root. So to get rid of the square root, I'm going to square both sides. So the square will cancel out the square root on the left side, and I'm just left with a 2x minus 3. On the right side, we know 5 squared is 25. Now this should be a problem that everyone should be able to solve. Just basic algebra, we need to solve for our variable x. So the first thing we need to do to get our variable x here all by itself is to get rid of this minus 3. To get rid of the minus 3, we need to add 3 on both sides. So if I add 3 on both sides, I'll get 2x equals 28. And then I need to divide by 2. So if I divide by 2 on both sides, to get rid of that 2, I get x is equal to 14. If we want to check, we can take this 14 and plug it back in there, and we should get a true equation. Alright, this last one is tricky. You guys are going to like this. It kind of combines a lot of different things that we've learned this year. So the first step is the exact same. We want to get the square root by itself. So to get the square root by itself, we need to move this negative 5. So we need to add 5 to both sides. So if we add 5 to both sides, we get x plus 7 is equal to x plus 5. So now, I'm sure you guys are thinking, okay, we need to square both sides. To square both sides, that is the next step we need to do, and this will cancel out over here on the left side, and we get x plus 7 is equal to. Now this is where we run into a little bit of a problem. We need to square this whole left side. Okay? If you write x squared plus 5 squared, that's going to be wrong. We need to square this whole side. What we're doing is x plus 5 to the second power is x plus 5 times x plus 5. Alright? Not x squared plus 5 squared. It's not going to give us the same answer. So this x plus 5 plus x plus 5, we can use our favorite way to distribute these, which is our box method. I'll do it down here. I'll change up colors. If you're good, you should be able to do these in your head by now. X plus 5, x plus 5, and we have x squared. We have a 5x, another 5x, and a 25. So we can combine our two middle terms here, and we end up with x squared plus 10x plus 25. Alright, this looks pretty complicated here. So we have x's on both sides now. What do we do? Well, we need to get all the x's on one side together. In fact, we need to get everything on one side together. So I'm going to move this x to the left side and get 7 is equal to x squared minus 9x plus 25. And I'm going to move this 7 to the right side and get 0 equals x squared minus 9x plus 2 plus 18. Alright, so this should look a little familiar. This is a quadratic. So we can solve it a couple different ways. We could do factoring. We could do the quadratic equation. I think factoring is the easiest method. So let's take a look at this. And we have 18 we're going to put here, and x squared here. And my middle two numbers here have to add up to minus 9. X and x go there, so we have to figure out what multiplies together to equal 18 and what adds together to equal negative 9. And I think minus 3 and minus 9 are going to do that. So we have x minus 3 and x minus 9 as our factors. So this equation here is the same as this equation here. Now I can make my factors equal to 0 to get my answer. So on the left side here, I can add 3 to both sides, and I get x is equal to 3. And on the right side, I can add 9 and get x is equal to 9. And we have our 2 answers. So that was a lot, putting together a lot of stuff that we've learned all year. We can't forget anything we've learned this year because it's always going to come up later. Hope you enjoyed. We'll see you next time.